What's up, guys? It's Coach Sharf. Welcome back to my online videos. Sorry this one's so late in getting posted up. Y'all kind of watching this in real time. I wanted to get it out Friday. I didn't get a chance to before I left, and then I had kind of a busy weekend. But I'm doing this right before school Monday morning. I'm gonna go immediately post it, so y'all still have plenty of time to watch this if you need to. Go back over to if you were out from class the last couple of days last week and get the notes and do the work that I posted onto Canvas. So this is the Pascal's triangle and binomial theorem notes. Hopefully shouldn't take too long. Again, we'll just quickly go over the notes. We're not going to go over the whole worksheet. I'm just going to show you all the triangle again, and then we'll do the few examples, so it shouldn't take too long. All right, so again, we got Pascal's triangle and the binomial theorem. So the binomial theorem shows us how to apply an exponent to a polynomial, specifically a binomial. So our example is x plus 3 to the 5th power. So next couple page slides are going to show y'all what would happen if we actually multiplied this out. And then we'll actually do this with the binomial theorem later. So this still ties into operations with polynomials because exponents are an operation. Remember your order operations, PEMDAS. Again, I'm going to move on quickly. If you need to pause it to get down the notes, that's fine. But I'm going to try to, again, not make this a 30-minute video. So x plus 3 to the 5th power means I'm multiplying x plus 3 times itself 5 times. So 1, 2, 3, 4, 5. You start the first two, do a quick and easy box method. Okay. So if you multiply those together and then you're going to cross them off, you say, all right, I got that one, but I still got to do it 3 more times. So what's going to wind up happening is you're going to have 3 more box methods. And before I go forward, again, I just want to say you don't necessarily have to write this down, but even with me just having it, I think it illustrates how, how much work and how long it would be to do this. But if you want to write it down, go ahead. So you continue multiplying by x plus 3. So we did 3 more times, 3rd time, 4th time, 5th time. So again, I already worked out on the math because I'm not going to sit here and do it because it's going to take a while. So you still got to multiply everything together. Your diagonals are still going to add up to be your like terms. And again, it'll be the same thing here, here, and here. And for all these diagonals down here as well. But eventually you get this. But again, the bigger point is, if you tried multiplying x plus 3 by itself 5 times, it would be this much work. And, if we asked you to do, something 6, 7, or 8 times, I mean, that would take up your entire test just trying to do one problem once it would get too big. So we want to try to figure out a way around that. So instead, we're going to use the binomial theorem and Pascal's triangle. So let's see worksheet for Pascal's triangle. So we got to start with that because we got to know what Pascal's triangle is before we can use it to help us with the binomial theorem. So we did the Pizza Palace worksheet. Again, it's up in the assignment in Canvas, but I just have the pyramid already posted here. Again, there's a lot of uses for this. The patterns were originally discovered by the Chinese thousands of years ago, and then it was kind of honed in, focused in, cleaned up a little bit by a guy named Blaise Pascal. He's a French mathematician in the 1600s. So mostly use it for permutations and combinations. There's a lot of, like I said, there's a lot of neat things with this, neat for me, I guess, being a math nerd. But we don't got to worry about that in terms of the binomial theorem. The only thing I need to know for the binomial theorem is, how to label these rows. So this 1 up top by itself is row 0, okay? Again, in terms of actual permutations and combinations, this means I don't have any choices, so I just have what I have. This is row 1. So again, in terms of the Pizza Palace workshop, I don't have any toppings, so I just have plain cheese pizza. Row 1, I only have 1 topping, pepperoni. So you can get 1 pizza without pepperoni, 1 pizza with pepperoni. Row 2 means I have 2 choices. So if I have pepperoni and sausage, so I get 1 plain pizza without either, 1 pizza with pepperoni, or 1 pizza with sausage. So 2 different 1 topping pizzas. and then I could get one pizza with both. So again, that's how it kind of works its way down. So the biggest takeaway again is labeling these rows. So this is row 3, row 4, so on, so on, so on down. If you mislabel these rows and you use the wrong one, when you're trying to do Pascal's triangle, you're going to have something that doesn't work out right. All right. So going back to active. So we use Pascal's triangle to identify the row we use to help us with the binomial theorem. So again, I have a smaller triangle written over here. The numbers in the row will be the coefficients we use for each term in expanding our binomial. So again, get that down. You'll see what it means if you don't know what that means right now, you'll see what it means in a second. I'm going to go ahead and make this bigger. So it'll let me, there we go. All right. Let me move my head out the way too. All right, so here are your steps for the binomial theorem. I'm gonna have to move my head out of the way a little more, I guess. Kind of put it right here in the middle. All right, so it's 6 steps. Again, I was trying to say this. I was trying to be as clear as I could the other day. I want you to be able to use the steps for your first couple problems, your first few problems as you're starting to do this, but you need to get away from trying to memorize the steps into actually knowing what you're doing. So instead of, again, I hope this makes sense. Instead of saying, okay, I got to expand x minus 4 to the 3 power. What's the first step? Use exponent to identify row in Pascal's triangle. So what do I have to do? You're not having to repeat the steps in your head. You just say, all right, I got to expand this. So I got to use row 3, which is 1, 3, 3, 1. So I write out 1, parentheses, parentheses, plus 3, parentheses, parentheses, so on, so on, so on. So we'll get to that on the next page in terms of doing the whole example. Again, here's your instructions. Here's your first 2. I know I got 4 up there. There's your first 2. Again, you can pause it to write them down. All right, here's the third one, fill in all the first sets of parentheses with the first term of the binomial. I think the first 2 were kind of self-explanatory. That's why I didn't do them. So for step 3, all the first sets of parentheses with the first term of the binomial, which again, in this case is x. So that's why we had the x first. Second term is -4. So for all my sets of parentheses going down, I have x and -4. Again, you can pause that to write down the step. Fourth step, it's kind of long. Again, the wording's a little not great, but again, it's more about seeing it in action. On the first set of parentheses, so, this first set, it's got the x in it. Stick the exponent on the set on the first term. So the set of parentheses on my first term x, I stick the exponent. When I say the exponent, I mean the original one, so stick 3. Then count down to 0 as you go right. So every x you see as you go to the right, you're going to count down 2, 1, all the way down to 0. The second set of parentheses, so the one with our -4 in it, we start with 0 and then we count up. And by the time we get to the last -4, we should be at 3. Step 5, calculate all your exponents. So what am I going to get when I actually take x to the 3rd power? What am I going to take what am I going to get when I take -4 to the 0 power? Again, in this case, x cubed is just x cubed, -4 to the 0 power, anything to the 0 power is 1. Last step, multiply it all together. 1 times 1 times x cubed is x cubed. So let's go look at the whole example. All right. So yeah, I'm gonna go kind of quick with this so my video is not 20 minutes long. So if y'all need to pause, pause. Okay, so for the first one, gotta move my head again. No, wrong thing. Sorry, guys. There. All right, so for the first example, x minus 4 to the 3rd power. So here's my triangle. This is row 0, row 1, row 2, row 3. So I'm using this. So I got to go 1. I don't want that color. 1, parentheses, parentheses, plus 3, parentheses, parentheses. This is step 2, plus 3, parentheses, parentheses, plus 1, parentheses, parentheses. All right. Step 3, take your first term and put in all the first sets of parentheses. So I'm going to go x, 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 x. Take your second term, put it in the second set of parentheses. -4, -4, -4, -4. And again, those instructions seem kind of long, but we've already got the first 3 knocked out. We identified the row, wrote out the numbers 1, 3, 3, 1 with the parentheses next to them, filled in the parentheses. Step 4, start with your first set of parentheses, stick the exponent on it that's equal to your original exponent, so 3. We count down to the right, and we should hit 0 on the last one, 3, 2, 1, 0. Okay, that one worked. So now we start with the second set of parentheses. So the ones around -4, start with 0 and count up 1, 2, 3. So again, I should hit 3. I should hit whatever my original exponent is on the last one. And again, just as a check for your 2 parentheses or your 2 exponents, excuse me, on each kind of term, they should always come back and add up to this. If they don't, you did something wrong. All right. So again, you know, the explanations seem kind of long, but we've already got our first 4 steps knocked out. So now I just got to calculate this, all my exponents. So I've got 1, x cubed is x cubed, -4 to the 0 power, anything to the 0 power is 1, plus 3, bring down your coefficient. Again, I'm not going to touch that till the end. X squared is x squared, -4 to the first power, anything to the first power is itself, plus 3, x to the first is x, -4 squared, so -4 times -4, positive 16. Then lastly, plus 1, even being the variable, x to the 0 power is still 1, and then -4 cubed. So again, you can punch that in your calculator or say, all right, -4 squared gave me 16, so I got to multiply it by -4 one more time. It's -64. And then you can finish it out by multiplying everything together. 1 times x cubed is x cubed. So I got x squared. So I know I'm going to have x squared. I got positive 3 times -4, which is -12. Here I've got 3 times 16 times x. So again, I know it's going to be x. Positive 3 times 16 is 48. And then positive 1 times -64 is all -64. So that would be my final answer. X minus 4 cubed is equal to x cubed minus 12x squared plus 48x minus 64. All right, take a second and breathe. Pause, put your pencil down if you need to. And then when you're ready, come back and unpause the video, go to the next problem. I'm gonna go ahead and go there. All right, so this is x plus 3 to the 5th power, the original one we started out with. And again, you can go back and look, but we should end up after we do this with x to the 5th plus 15x to the 4th plus 90x cubed plus 270x squared plus 405x plus 243. I think I did that right. All right, so 5th row, again, you can see, even though I got it covered up a little bit, I drew this out to one more row. This is the 5th row, 1, 5, 10, 10, 5, 1. So I already have that written out. So again, first 2 steps done. Row, numbers written out with the parentheses. Now fill in your terms. First term is x. So x, 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 x. Ooh, it's bad x. All right, second term, 3. No. So 3, 3, 3, 3, 3, 3. All right. So first 3 steps done. Step 4, start your first term, put your exponent, count down to 0. 3, 2, 1, 0. Then your second term, start with 0, count up. You should be able to count up to 5. 1, 2, 3, 4, 5. All right, we got to 5. And again, if you want to double check, make sure these all add up to 5. 5 and 0 is 5, 4 and 1. 3 and 2, 2 and 3, 1 and 4, 0 and 5. All right, so first 4 steps knocked out. Now just take my exponents, or calculate my exponents, excuse me. So I've got 1, again, x to the 5th, just x to the 5th. 3 to the 0 power is 1. Bring down your 5, x to the 4th is x to the 4th. 3 to the first is 3. Bring down 10. X cubed is just x cubed. 3 squared is 9. 10. X squared is x squared. 3 cubed is 27. I know I'm running out of room a little bit here. I'm going to try to fit it in. Plus 5. X to the first, I'm doing up here. X to the first is just x. 3 to the fourth is 81. And then lastly, again, I'm kind of squeezing in here. 1. X to the 0 power is still 1. And then 3 to the fifth is actually going to be 243. All right. So there's those. Now I just got to multiply everything together. And if y'all notice, hopefully y'all did, you know, I had x plus 3 to the fifth power. Again, all these signs originally are positive, so everything should be positive. No negative signs to worry about. 1 times x to the fifth is x to the fifth. 5 times 3 is 15, x to the fourth. 10 times 9 is 90, x cubed. 10 times 27 is 270, x squared. Here, 5 times 81 is 405x. Still got the x. And then 1 times 243 is 243. And even though it's a little crooked, I still got what I said I think I should get. All right, got one more problem to do real quick. So this one's going to throw a couple wrinkles in there, okay? First wrinkle is now, well, it's going to look like the wrinkles, y'all. Let me back up. First one is I'm using y instead of x. That doesn't matter. Variable, doesn't matter. Second one is I got the coefficient here. That's going to be the most significant thing. And then even though the first problem had a negative, I didn't really talk about it. But with this being negative, you're going to see it's going to wind up switching the signs on my terms. So it's going to alternate between positive and negative. Y'all see that at the end on my final terms. But more importantly, what happens when this is specifically -1. So we'll get to all that in a second. Again, I know I got the triangle covered up, but this is the fourth row, 1, 4, 6, 4, 1. So I already got it written out. Again, just trying to save us a little time. So write that out. All right. So first term is 2y. So 2y, 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 2y. Then -1. It's my second term, -1, -1, -1, -1, -1. All right, first term, start with your exponent. 4, count down, 3, 2, 1, 0. Second term, start with 0, count up, 1, 2, 3, 4. Now we got to multiply out our exponents, take our exponents. So 1 comes down, 2y to the fourth power. Again, some of y'all might want to try to think about it like this. When saying 2y to the fourth power, it's really 2y times 2y times 2y times 2y. Some of y'all might be able to think about it better that way. But again, kind of the easier trick is when you have it like this, just treat it like 2 to the fourth power, y to the fourth power, 2 to the fourth power is 16, and then y to the fourth is just y to the fourth. -1 to the 0 power, anything to the 0 power is 1, plus 4. Again, 2 cubed y cubed, so 8y cubed. -1 to the first is -1. 6, 2 squared y squared, so 4y squared. -1 squared, so -1 times -1 is +1. Plus 4, 2y to the first, you can just do 2y for that one because anything to the first power is itself. If you want to do 2 to the first, y to the first, I guess that's fine, but you still get the same thing. -1 cubed. So now -1 times -1 times -1. You can multiply that out. You can punch that in your calculator, or again, -1 squared is +1. So just multiply it by -1 one more time, get -1. And then lastly, 1, 2y to the 0 power, even with the coefficient, anything to the 0 power is still 1. -1 to the fourth. Again, you can put in your calculator or say multiply -1 by -1 one more time, gives me +1. So again, the biggest thing was with that coefficient, but all you're gonna do is, raise the coefficient to the power and the variable to the power. And then with the negative ones, this is one of those little tricks they like to throw out. When you have the negative ones, it's just going to alternate between +1 and -1 all the way down. So now multiply everything together. 1 times 1 times 16y to the 4th is 16y to the 4th. 4 times 8, 32y cubed times -1, so -32y cubed. 6 times 4y squared is 24y squared, and then times the 1's not going to do anything, so 24y squared. 4 times 2y is 8y, times -1 is -8y, and 1 times 1 times 1, of course, is 1. So again, you know, even on the other problem where we had the -4, you know, my signs wound up alternating down here. Again, this first one's, you know, even though there's not a plus, this is still positive, so positive, negative, positive, negative, positive. You know, if there had been another term, it would have been negative. So that's what happens when your second term is negative. I'm not going to try to give you anywhere the first term's negative. That'll get confusing. And again, specifically with this example, when this is -1, this just alternates between 1 and -1 going all the way across. So that's your final answer. All right, there we go. Still think I went a little longer than I wanted to, but got through it. Again, as always, if you got any questions, let me know. I'm about to send a reminder message out right now, letting y'all know that this is posted to do your work. Again, you got till this is going up on Monday, the 23rd. Going to stop recording this at 8:17 in the morning. You have until tomorrow at 11:59 p.m. to post everything for full credit. All right, see you guys later.